Okay, ji. So complex number, lecture number 3. In the first lecture, we went through the very basic of complex number, introducing iota. Then we made sure that we find out the roots through the quadratic formula. And then we made sure that we understand the formula of sum of root and product of root, through which we found out the equation through the roots itself. Then we made sure that we complete the representation of data. In the second lecture, we introduced the different forms or different complex number in the form of real and the imaginary, where addition and the subtraction of complex number took place, whereas we also covered down the multiplication and division of the complex numbers, right? So you need to also subscribe my channel, that is Math Fix by Sir Adil Jatoi. And now moving on to complex number, lecture number 3. Okay, lecture number 3. Now we are doing square root of a complex number. So square root of complex number. Let's say that a complex number is given as what? 3 plus 4 iota, but obviously it is an under root. And from under root 3 plus 4 iota, we know that we need to have the answer in the Cartesian form, that is a plus iota b. That means I need to have this in form. That means I need to have the under root 3 plus 4 iota in the real and the imaginary form. So if we just look at it, look into this, that under root 3 plus 4 iota, if I just make sure that this square under root is obviously eliminated by introducing square on both sides. So obviously the square is cancelled out with the under root, whereas a square is introduced on this side. So particularly this should be 3 plus 4 iota is equal to a plus iota b whole square. And what are we actually doing? We are squaring on both sides. When we squared on both sides, so automatically this under root is cancelled out, right? So we are left with 3 plus 4 iota is equal to a plus iota b whole square. So moving on to this, we know that it is 3 plus 4 iota, and this a plus iota b square can be opened as through the identity, which is a square plus 2 iota AB plus iota square B square. So iota square, you already know it is what? -1. So we can write this thing down as 3 plus 4 iota is equal to A square plus 2 iota AB negative B square. Now A square and negative B square represents the constant number, which is the real number. So a square minus b square, whereas 2 iota ab represents the 4 iota. So if we just comparing imaginary value of z and real value of z. So pick up the imaginary value first so that iota can be cancelled out. So this should be 4 iota is equal to iota AB. Iota and iota is cancelled. So in the end, what you have is AB is equal to 2. 4 is divided by 2, so you're left with what? 2. So let's make A the subject. So this should be 2 upon B. Now when we have this 2 upon B as what? As a subject equation. We also know that we have the real value of Z, and the real value of Z is 3 is equal to a square minus b square. And we already made sure that we make the a the subject. So this is 2 upon b whole square. If you just see that this is substituted in this a. So when this is substituted in this a, so this becomes what? 2 upon b whole square. Whereas 2 upon b whole square, we can also write minus b square. So this becomes 3 is equal to 4 upon b square minus b square. Can we just take down the LCM of b square? So it will give me b to the power 4. And 3 is equal to 4 minus b to the power 4 upon b square. And just working down with the working, 3b square is equal to 4 minus b to the power 4. Now we can see that we have disguised quadratic equation here. Your disguised quadratic equation becomes b to the power 4 plus 3b square. This is plus 3b square minus 4 is equal to what? 0. So if we just take down common representation, that means this b to the power 4 can be written as x square is represented by, or I can just say x is represented by b square. So this becomes x square plus 3x minus 4 is equal to what? 0. So x square plus 4x minus x minus 4 is equal to 0. X plus 4 minus 1 x plus 4 is equal to 0. That means we have x minus 1 is equal to 0, x plus 4 is equal to 0, x is equal to 1, x is equal to minus 4. So if we know that x was b squared, just write down b squared again. So we have negative 4 here. So can we just say that this should be plus minus 1, and considering this, it would be under root, and under root 4 will be 2, and we have negative 1 as well. So it should be plus minus 2 iota. So what answer do we have? 2 plus iota and 2 minus 2 minus iota will be the two roots from where we are getting the answer. If please kindly look into this, that this b square is equal to negative 4. B is equal to under root negative 4. B is equal to under root negative 1 under root 4. So B is equal to iota 2. So obviously when we have this under root, we solve it through plus minus. So considering this, that we have the two equations. So this would be what? Plus 2 plus iota minus 2 minus iota in the sum. Now, you need to also understand that since we know that plus minus 1 were the values, right? And b was also 2 iota. So if I just, to get the second answer of the root that we got as 2, because the question was given as a is equal to 2 upon what? B. The question was a is equal to 2 upon b. So let's just work out this through and get you the second answer, which was directly written. So let's say a is equal to what? A is equal to 2 upon b. So since a is equal to 2 upon b, so 2, if we just take plus 1, so this should be 2 upon 1. So a becomes what? 2. If a is equal to 2 upon negative 1, so a becomes what? Negative 2. And the question was a plus iota b. So we got to know that the following, that if plus 1 is used, then we got plus 2. So that becomes the first root. If we have minus 1, we will be getting minus 2. So this becomes the second root. Kindly understand that if you use the iota in a is equal to 2 upon b. So that means you will be using plus iota and negative 2 iota. And when 2 upon 2 iota is used, then obviously to remove iota, you need to introduce iota and iota again. To remove the iota, you need to obviously uh, introduce the iota in the numerator and iota in the denominator, which will become 2 iota, and this will become 2 iota square. Considering that 2 is cancelled, and knowing this that iota square is negative 1, so this will become negative iota. So when 2 iota is used, so in the end you will end up having what? Negative iota, because iota square, square becomes what? Negative. Considering this, that using the iota form, the solving to find out the other root will get difficult. So that is the reason we made sure that we took the normal number of b. And that was introduced in the a to get the second value of the Cartesian form, which was a plus b iota. A square minus 2 a iota b plus iota square b square. This is another example of square root. Under root minus 5 minus 12 iota is equal to a plus iota b, where we made sure that we use the square root. And moving on, that we know that this is already plus. So let's just move that 5 minus 12 iota is equal to a square minus b square plus 2a iota square. How did we get minus b? By solving b square will remain b square, whereas this a square becomes what? Negative 1. So this will become negative b square. Negative b square is taken down here. So this should be 5 is equal to a square minus b square, whereas negative 12 iota is equal to what? To a iota b. Now, whenever we try to solve down, we try to solve down the imaginary values first. Why do we do that? So that iota and iota are cancelled out. So iota is cancelled out. And considering this, minus 12 is equal to 2ab. So minus 6 is equal to a and b. So let's just make a the subject. Minus 6 upon b will be the subject of A. Let's just substitute this A in the other equation, that is the real value equation. So this should be 5 is equal to minus 6 upon B whole square minus B whole square, right? B square. So let's say 5 is equal to 36 upon B square minus B square. Taking down the LCM and multiplying in the on the other side, this should be 36 minus b to the power 4. So b to the power 4 plus 5b square minus 36 should be equal to what? 0. This involves the disguised quadratic equation where x can be b square. So x square plus bx minus 36 is equal to what? 0. We can see 9 into 4 is 36 and 9 minus 4 becomes what? 5. X square plus 9x minus 4x minus 36 is equal to 0. X plus 9 minus 4, x plus 9 should be equal to 0. One value of x is 4 and the other value of x is negative 9. But we knew that x was b square. So b square is equal to 4. B square is equal to what? Minus 9. B square will be plus minus 2. And this should be plus minus what? 3 iota. As I said that solving this will be solving or doing something lengthy. So we will only be taking the normal values to get the values of A. Now we know that the value of A that we took was minus 6 upon B. So when B is equal to 2, so A will be minus 2 upon 2. So A becomes 3. And when, similarly, when B is equal to negative 2, so it should be negative 6, negative 2. So A becomes what? 3. So when we use the value 2, the real value is your Cartesian form is of real value of Z plus imaginary value of Z, which is a plus b iota. So when b was 2, A becomes 3. So this is 3 plus 2 iota, right? This is positive and this is negative. So this is minus 3 plus 2 iota, and A plus B iota means that we have 3 minus 2 iota. So these are the two roots that we are getting through the square root of the complex number. That means 5 minus under root 5 minus 12 iota. When changing it to A plus iota B, the answer is minus 3 plus 2 iota and 3 minus 2 iota. Now, let's work upon representation of complex number on Argand diagram. Let's just work with, let's say Z1 is 2 plus 2 iota, Z2 is negative under root 3 plus iota, Z3 is negative 1 negative under root 3 iota, and let's say Z4 as 3 minus 3 iota. Now we have four different complex number. Let us just create the Argand diagram now. Considering that let's just draw this up. So your x-axis represents the real value of z. Your x-axis represents the real value of z, where your y-axis represents the imaginary value of z. What does imaginary value of z means? That your imaginary value of z represents through the iota, the 2 iota, 3 iota, 4 iota. Let's write down 5 iota. So this can be negative iota, negative 2 iota, negative 3 iota, negative 4 iota. Similarly, here we can have 1, 2, 3. So similarly, we can have negative 1, negative 2, and negative 3. Now, real value of z and imaginary value of z. We knew that our first was 2 plus 2 iota. So can we just say that 2 plus 2 iota is positive quadrant that we have? So 2 plus 2 iota will be here. Now, if we have 2 plus 2 iota, that means there are two things that are in consideration as well. So this represents the line of Z1, which is 2 plus 2 iota. 2 plus 2 iota, right? Now, this particular thing, when moved anti-clockwise, so this represents the alpha. And the quadrant that gives me the answer is of alpha as well. That means positive alpha is the answer here. On the other hand, this thing will also give me the modulus through the z modulus of what? Using the z value. That means this can give me the length as well as this will give me the angle. Let's just work upon the z2, negative under root 3 plus 1. Now, negative under root 3 is somewhere less than -2, and the other value is plus iota. So that means this value will be here. So if this value is here, so let's just draw up for Z2. So this represents Z2, which is negative under root 3 plus iota. Whereas the angle here is always in pi minus alpha, right? Because this will be the angle, but we will be needing this angle. So if this angle is taken out, we will always be finding out anti-clockwise using the pi minus alpha method. So for second quadrant, you can always have what? Pi minus alpha. Now, in complex number, the two quadrants go anti-clockwise, whereas two quadrants go clockwise. So if two quadrants are going clockwise, so this will be negative alpha, and this should be negative pi minus alpha. But let's just work upon with Z3, -1 and -3. -1 and -3 is somewhere here. So this becomes your Z3 line. This is your Z3, which means -1 and negative under root 3 iota. And this represents negative pi minus alpha because this goes clockwise to the second quadrant for the clockwise. Overall, that this is your third quadrant. Then we have is Z4. Z4 is 3 minus 3 iota, which is here. So if we just draw the line, we draw the line till the point. This represents Z4, which is 3 minus 3 iota. And here the angle will be negative alpha. Now, this is your normal argon diagram with normal real value of Z and imaginary value of Z. So that means these are your straight lines covering up the argon diagram. Now, there are 2-3 things that you need to work upon. That means your modulus of Z, right? And modulus of Z is representing the distance of complex number from origin, which means the distance of this distance is your Z, this distance becomes Z, where this distance becomes your Z. So that will be the modulo of Z1, this will give me modulo of Z2, this will give me modulus of Z3, this will give me modulus of Z4. And the formula to represent the modulus value is same as that modulus of Z is basically under root real value of Z whole square plus imaginary value of Z whole square. Because normally it is creating a right angle triangle. If you just look at this, it is creating your right angle triangle where you know the base that is represented through what? Real 2, and you know that this will become what? Imaginary of what? 2. And it is creating 90 degree. Since it is creating 90 degree, we can automatically say that Pythagoras theorem is used. And Pythagoras theorem is always hypotenuse square is equal to base square plus what? Perpendicular square. So eventually we will be using this, but we'll be using this in the form of real value of Z whole square plus imaginary value of whole square of Z with the under root. Whereas the other thing the examiner would want you to find is the angle. Right? And for the angle, again, it creates a right angle triangle. You know the opposite value and you know the what adjacent value? So obviously tan theta will be used, opposite upon adjacent. Tan theta, and opposite is imaginary value of z and adjacent is real value of z again. So similarly, if you want to find out the angle in the complex number, the angle is written as, in the complex number, the angle is written as what? Alpha, and it is also written as the argument taken out. So that means to find out the argument z, that means argument of complex number, we'll be needing the argument of the complex number, and argument of the complex number will be alpha is equal to tan inverse imaginary value of z upon real value of z, where your argument is basically is greater than equal to what? Minus pi, less than equal to what? Pi, which means this gives you positive anti-clockwise. This gives you positive anti-clockwise, and this gives you negative clockwise angles, because this will give you alpha and pi minus alpha, and this will give you negative alpha and negative pi minus alpha because of the clockwise rotation. So, considering these, let's just work upon Z1. Your Z1. Your Z1 was 2 plus 2 iota. Z1 was 2 plus 2 iota, right? So if I want to take out the modulus of Z, this should be under root 2 square plus 2 square, which means 4 plus 4 is under root 8, and under root 8 is 2 under root 2. Under root 2 is 2 under root 2. So that means the modulus or the length that we are getting is 2 under root 2, which is also your r in the trigonometric form, which is also represented by r in the trigonometric form, because the representation of complex number will be needed. Now let's just work upon the angle. Your angle is alpha tan inverse, again 2 upon 2, which is alpha is equal to tan inverse what? 1. So this would be pi upon 4. This will be pi upon 4. So considering the information that we got is, we can always write down this thing in the trigonometric form. Your trigonometric form was r cos theta plus iota sine theta, which means 2 under root 2 cos pi upon 4 plus iota sine pi upon 4. Now, this will represent what? Your trigonometric form. Similarly, your exponential form was there. And in the exponential form, this will be that 2 under root 2 e 2 under root 2 e iota pi upon 4. Similarly, there was another polar form, and your polar form will give me the answer as 2 under root 2 less than what? Pi upon 4. So the Cartesian form was 2 under root 2. Your trigonometry form was 2 under root 2 cos pi upon 4 plus iota sine pi upon 4. Then your exponential form was 2 under root 2 e iota pi upon 4 is in the power. And lastly, the polar form. We made sure that we do the representation of the data in the lecture 1, where we understood the trigonometric form, how the R was taken. Again, the R is taken through the modulus formula. So theta was taken from the tan inverse formula. And similarly, we also noted the exponential form and the polar form. So this is what we got in lecture number 3 of 2 plus 2 iota. How to find out the modulus, which is 2 under root 2, and tan inverse, which is pi upon 4. Now, if we just look at this, so this answer, this is your alpha, this becomes pi upon 4, whereas this becomes z modulus, which is also r 2 under root 2. So this line length is 2 under root 2, whereas this angle becomes pi upon 4 through the given 2 plus 2 iota. 2 plus 2 iota. So this was about it from lecture number 3. We will be continuing this in lecture number 4 using Z2, Z3 and Z4 data to make sure that we change Z2, Z3, Z4 in the trigonometric form, in the polar form and the exponential form, finding out the length, the modulus and also the angle of the second quadrant, of the third quadrant and of the fourth quadrant, but using what? Anti-clockwise rotation for what? The second quadrant and clockwise rotation for the third and the fourth quadrant. Thank you.